Data Analysis Exam Help. For any help regarding data analysis exam help, visit https://www.statisticsexamhelp.com, email support@statisticsassignmenthelp.com/ or call us at +1 678 648 4277. Problem 1. Provide a brief answer to each of the following questions. A. Suppose that you have a choice of collecting a random sample of 20, 40, 80, or 160 measurements of a random variable y. You will use the sample to compute the sample mean mi, which you will use as an estimate of e, y. Draw a sketch of the probability density of mi for n equals 20 measurements and superimpose on it a sketch of the same density for n equals 40 measurements. B. Plot the standard deviation of the sample mean versus the number of measurements in the sample. How does the standard deviation at n equals 160 compare to the standard deviation at n equals 20? C. Is the sample mean a consistent estimate of e, y? Y. Solution. A. Plot should look normal. Standard deviation for n equals 40 should be 0.70. Standard deviation for n equals 20. Peak for n equals 40 should be 1.41. Peak for n equals 20. B. Standard deviation of sample mean should decrease as n minus 1/2. C. Yes, because lim var mi 0 n. Statisticsexamhelp.com. Problem 2. You are studying the cadmium concentration, Y, in trout tissue in a large lake. You catch 10 trout and measure the following cadmium concentrations: mg/L 0.1060, 0.040, 0.128, 0.225, 0.167, 0.024, 0.317, 0.072, 0.099, 0.029. A. Considering the possible values of the data, what would be a reasonable assumption for a probability distribution for the population and why? B. Derive a two-sided 95% confidence interval, 5% significance level, for the expected value of sediment concentration, using a large sample assumption. Do you think this assumption is justified? Why? Note that the 2.5% lower and upper critical values for a unit normal probability distribution are -1.96 and +1.96. C. Carry out a two-sided large sample test of the hypothesis H0, E, Y equals 0.2. Is H0 accepted or rejected at a 5% significance level? Solution. A. A histogram of the data suggests that Y is exponentially distributed. B. Sample mean is mi equals 0.12. Sample standard deviation is SY equals 0.094. Statisticsexamhelp.com. If we adopt a large sample approximation, we assume that the sample mean is normally distributed with mean E, mi equals E, Y, the unknown true mean, and standard deviation SD, mi equals SY/N1/2 equals 0.094/10, 1/2 equals 0.03. The critical points for a two-sided 95% confidence interval are given by MYL 0.95 equals mi SD, mi 1.96 equals 0.12, 0.03, 1.96 equals 0.063 mu, 0.95 equals mi plus SD, mi 1.96 equals 0.12 plus 0.03, 1.96 equals 0.18. So we infer from the data that E, Y, probably lies in the interval between 0.063 and 0.18. Based on our experience with stochastic simulation of small exponential samples, the large sample approximation is reasonably good for samples as small as n equals 10 at significance levels of 0.05 or larger. C. Find the two-sided large sample acceptance region for a significance level of 5% from MYL 0.95 equals E, YH0, SD, My 1.96 equals 0.2, 0.03, 1.96 equals 0.14 mu 0.95 equals E, YH0, plus SD, My 1.96 equals 0.2 plus 0.03, 1.96 equals 0.26. Since the sample mean estimate might equals 0.12 lies outside the acceptance region, we reject H0. Problem 3. StatisticsExamHelp.com. Consider the following four values of the independent variable, time, and the dependent variable, change in total dry biomass relative to long-term average, in a temperate forest. Time, months 2.0, 2.54.08.0 biomass, kg/m 2.73.3 minus 1.69.0. Compare the following two regression models by following the indicated steps. YL, X, A2, A2X, YS, X, A2, A2 sin, X, A. For each model, derive the least squares estimate for A2. You can do this by minimizing the sum of squares error directly or by using the following expression, H2 H y, where H equals x1, x4 equals 2.0, 2.54.08.0. For the first model, H equals sin x1, sin x4 equals 0.91, 0.60 minus 0.760.99. For the second model. StatisticsExamHelp.com. B. Plot the regression line over the range of measurement x values and calculate the sum of squared errors or SSE. The easiest way to do this is to read the error values directly off your plot. Which line gives a smaller SSE? C. Which regression model do you prefer? Why? Solution. Quiz 3. Solution to problem for function quiz 01_3 sol 4% generate data zmias sadface 2.548 imias equals zmias asterisk sin zmias plus 2 asterisk normand 0.114 hl equals zmias hs equals sin zmias a2 lat equals inv hl asterisk hl asterisk hl asterisk imias a2 lat sadface hl asterisk hl backslash hl asterisk imias a2 shat sadface hs asterisk hs backslash hs asterisk imias ssel sadface imias a2 lat asterisk zmias asterisk imias a2 lat asterisk zmias sses sadface imias a2 shat asterisk sin zmias asterisk imias a2 shat asterisk sin zmias x sadface 1.01:9 yl equals a2 lat asterisk x ys equals a2 shat asterisk sin x close all figure. StatisticsExamHelp.com. Plot zmias imias asterisk hold on plot x yl r hold on plot x ys b return a2 lat equals 0.8781 a2 shat equals 5.3151 ssel equals 32.1493 sses equals 24.4308. StatisticsExamHelp.com. Problem 4. Consider the following random sample of 6 measurements of a random variable y distributed uniformly between 0 and c. 0.8775.03190.85370.79460.34090.0080. A. Use this sample to derive an appropriate estimate of c, the upper bound of the random variable y. B. Write a stochastic simulation program that evaluates and plots on a normal probability scale the cumulative distribution function of the estimator you use to compute c. C. Suppose that your program produces the following plot when a value of c equals 1.5 is used in the uniform random number generator used to generate the